seems cool. They really talked about differential equations because I don't know what happened. I wrote that on your notes. There's this whole class in college called differential equations. Yeah, people call it. There's a whole course on differential equations. Basically, it's just an equation involving a derivative. Sometimes we separate like the dx, we actually write over here and we say dy equals. But for us, we're going to talk about solving these by doing the integral, which means we're going to do this just kind of like we've been doing, but it's just going to look a little bit different than just the integral sign right away. They talk about the order of the differential equation is the order of the highest derivative, which means usually when we're taking an antiderivative, we just are dealing with the first derivative, but technically speaking, they could give us the second derivative and that's what we would all the way backwards. Technically, they could give us like a fifth derivative and that's what we would all the way backwards. So, kind of just understanding what it's asking, kind of like the one on the test where it gave you the derivative and the point and you have to recognize the antiderivative, right? So, let's find all functions y that satisfy this differential equation. Basically, what we can do here is we can kind of sort of integrate both sides, but if we wanted to integrate this, think about what's missing. We need that dx there. So what if I just multiply the dx over here? Can I do that? dy over dx just means the derivative. What if I did that? What if I wrote dy equals 3x squared plus cosine x? So differential equation, kind of separate the y's and x's. And now, what if I said, let's integrate both sides? We forgot to talk about Jacob yesterday on the free response that Jacob noticed that the one problem spelled out a bad word. Did anybody else notice this? The h prime, the integral of h prime of t. What would the integral of this side be? How would you integrate dy? If I put a 1 dy. What if I said integrate 1 dx? What would you say? Which would be x, because you add 1 and you divide by it, right, with respect to x. So what do you think the integral of 1 dy is going to be? It's just 1. Eventually, down the line, we're going to talk about sometimes it's not going to be just y, and it'll be more complicated, but for now it's just y. Every time it's just dy. And then over here, we're going to integrate, we're going to do the antiderivative just like we've been doing, except there's no bounds, right? So that's why it says find all functions, because there's no bounds. It's called an indefinite integral, which means you have to remember to put the plus in there. Because all functions, you can get any function. But other than that, it's exactly the same thing. So if you do the rule, right, sometimes you guys just see it, but if you do the rule, remember that you leave the 3 alone, you add 1 to the exponent, and you divide by it, which means those 3s would just cancel out, and if you recognize that, you don't have to show that. And then you got to know your trig ones. What is the integral of cosine? Just sine, right? Because the derivative of sine is cosine. The integral of sine is negative cosine. I really always look into it, so I think it's just plus sine of x plus c. And that is what we call the general solution, or saying that we found all functions that satisfy this differential. is a lot of your homework today, right? The other part that we're going to take is what if they ask you for specific or like on the multiple choice test. What if they give you a point and they ask you to solve for an equation? Then you can actually solve for C. Oh wait, what about this one? This one looks exciting. I'm going to separate my variables. I'm going to put my dt with my t. Right, that's one. We're going to learn a way in this chapter that we don't have to do this all the time. But today, I really want you to just think about, think about what function would have that root. And really, we haven't done anything like this before, because we haven't done something that they use the chain rule to get this root. Do you agree with that? Because we have our cosine t cubed. Think about the derivative of t cubed is 3c squared, right? So really, you're just thinking about what is the integral of cosine, sine, right? And it's going to be sine of t cubed. And I don't have to do anything with this 3t squared, because that's just like multiplying by the chain. So the integral looks a lot more complicated than its antiderivative, but you can always check, right? If you know what this is, think about it. The derivative of sine is cosine of t cubed, and then times the derivative of t cubed is 3t squared. We haven't really done a lot of that yet. Today they're going to throw those in there and make you kind of think about, all right, what would this be to get that? And don't forget your plus t. And then don't forget over here, right? So you should say like, right? That's some good branch, right? And again, that would be the general solution. Oh. At least there's like I know, because it was on the bottom. I used this word yesterday, initial value problem. A derivative or a differential equation, when they give you a point, it's called an initial value problem. It's so they give you a point so that you can solve for C. It has a specific solution or a unique solution called the particular solution, which means that instead of finding the general solution of plus C, you can find the exact one, which is what we saw in the AP multiple choice. They wanted you to find the exact solution and then evaluate it at another value. And again, this is a little more complicated, right? Because it's e to the 2x up there. So step one, before I'm going to use my point, I'm going to just integrate like I was doing the other one. So I'm going to move my dx over here. I'm going to have 2y equals e to the 2x minus 3x dx. And I'm going to integrate both sides. I got to use that. So the integral of e to the x is x, derivative of e to the x is x. We have an integral here of e to the 2x. So we have to think about what would the inside derivative of that. So what function would have that as a derivative? Thinking about that whole idea of the chain rule that we have to multiply by that function up there. So we're going to have a 2x kind of antiderivative. Definitely going to have to use the 2x. You get stuck on these, some people see a lot. The way that I think about it is take the derivative of this, and if it doesn't exactly match, think about what you need so that stuff would cancel out. Like, what would the derivative of e to the 2x be? 2e to the 2x, because you have to multiply by the 2x, but there's no 2 up here. So what has to be in front of here? Right, so there has to be a 1/2 out here so that when you take the derivative that those 2's would just cancel. It shouldn't get much more complicated than that today, than needing the fraction out front. But again, it just kind of makes you think about your antiderivatives a little bit more. And then this one is just our power rule, right? So that's just minus 3x squared over 2. Raise it up 1, divide by that. Don't forget your plus c, because if you forget your plus c, then this whole point that they gave me it's not relevant anymore. And then this is really what we did last semester when we first talked about antiderivatives. We just didn't talk about this integral time. That if I give you a point now, just like we talked about yesterday, we can plug in x and y, you can solve for c, and you can find the specific solution to that equation. So y is 1/2. Squared. Y is 3 as plus c. We see not super great here, but I could move this over minus this. Right? It's just 2. And I could subtract this over, so I'm going to say 2 minus 1/2 squared. Questions on where I get that? Right? E is just a number, but I can't add E. I mean, I guess I could get a constant here if I wanted. I don't know. I'm just saying all that's my C. Okay? That's all a constant value. It's all just a number. So if I was going to write my answer, that's what I'm going to write. Like my final solution is 1/2 e to the 2x minus 3 halves x squared plus 2 minus 1/2 e squared. And again, it's up to you on how much you want to combine that together. Again, really good idea to go back to the book. Now they combine it to see if they write it a little differently than what I write. That's all we're doing today, because tomorrow we're going to talk about which means using these differential equations to graph different points. When you look at your homework today, you're going to see some great pictures, and we'll talk about those tomorrow. But today I really wanted to just practice these indefinite intervals, practice solving these differential equations, because it really is a big part of the AP exam, because there's so much stuff we can do with them. So, work on this today, right? Lots of time. 3 through 18 multiplied with 3, 49, and 50. If you have questions, let's talk about them now. Instead of waiting until tomorrow. And then if you have other questions on the test still, today we're ready to do it. So we'll come back tomorrow. We'll spend the majority of the time talking about short field. And then Thursday I might record a little bit of doing some worksheets.